Hi everyone. Today we're going to be talking about something called complex numbers, which are different than ordinary numbers that you're used to seeing. But before we can talk about what complex numbers are, we need to go over how to simplify radicals, because guess what? Complex numbers involve a radical. So if you do not understand how to simplify a radical, then we need to make sure we understand that first. Some of this should be a review because we have technically gone over how to simplify a radical. But if you don't remember, it's okay because I'm going to show you how to do it again. Okay, so let's get started on example 1. Okay, so example 1. Okay, so I'm trying to simplify this radical, which I want to know what is the square root of 16. Now, in order to simplify a square root, we're looking for pairs of numbers. If something is a perfect square, that means two of the same exact number can multiply to equal that number. Okay, so like, for example, you probably already know that the square root of 16 is 4. Okay, I know that you guys probably already know that. Now, I want to talk about, well, why is it 4? Okay? Well, it's because we're looking for pairs of numbers when we have a square root. 16 breaks down into 4 and 4. Okay, so remember, if you have a pair of numbers, okay, you circle the pair, and for every pair, one number hops outside the square root. So 1, 4 hops outside the square root. There's nothing left over, so the square root of 16 is 4. Now, technically, you could have kept breaking this down. Like, you could have said 4 breaks down into 2 and 2, and 4 breaks down into 2 and 2, which means we have 2 pairs of 2. So this is separate from the 4, so ignore the 4s for right now. Okay, so like you could have circled the 2s and the 2s. So I have 2 pairs of 2s, so that means that 2 2s hop outside the square root. Okay, and if you have more than one number, you multiply them together. So 2 times 2 is 4. Guys, so you can like keep going, but technically right when you spot a pair, like I saw a pair right there, right when you see a pair, technically you can stop. You don't have to keep breaking the numbers down into their prime factors. Okay. Well, knowing that, now these next 3 examples are not perfect squares, which means we're going to end up with a square root in our final answer. So this one we didn't end up with a square root because nothing was left over. Okay, but in the next 3 examples, something will be left over, which means we're going to end up with a square root. So let's see what happens in these next 3. I'm already excited.